All right, hey, challenge for you today. If you dare accept it. Um, and also a new discussion question. But first, the challenge. What is an ellipse? By definition, well, there's two ways to define it. One is it's a slice of a conic section. And I already visualized that or tried to make a drawing of it in one of the last videos. And certainly you could, go on YouTube and you say, what is an ellipse? And you'll probably get some fantastically generated graphics. But the definition we're going to use, and the definition, the operable definition that most people use, is as follows. An ellipse is the set of all points such that the sum of the distances between two given points is equal to a constant. Wow, I wish there was an easier way to say that, but let me show you what it means. You're given 2 points. There's 2 points. Somebody came along and they said, here you go, boom, and they put those points there. They gave you those points. These points are called the foci. Each one is a focal point, and the plural of that is foci, but focal points. It's the set of all points such that if you add this distance to this distance, you get a constant. And in fact, this is classically how you draw an ellipse. How do you draw a straight line? Take a piece of string and stretch it tight, or take a straight edge, but take a piece of string and stretch it tight. How do you draw a parabola? That's actually not as easy, so we're going to pass on that. How do you draw a circle? Well, a circle is an ellipse. It's a special case where these two focal points are the same. If you bring these two focal points together, that becomes the center of the circle. How do you draw an ellipse? You could take 2 tacks, press the 2 tacks into something, I don't know what, piece of cardboard, and then take a piece of string, an inelastic piece of string, a non-stretchy piece of string, and the length of the string is that constant. Take the string and keep it tight and go around like that. You have an ellipse. You see, wherever you are on the ellipse, say you're over here, this length plus that length is equal to the length of the string. Now notice what I've done right here so far. Perhaps notice what I haven't done. There's no coordinate system. No coordinate system. No x and y. This is really a definition really purely from geometry. It doesn't involve any algebra. But here's what we're going to do. We're going to join it or wed it with algebra in the following way. Let's take an xy coordinate system. And to keep things simple, and because they wind up not being simple, I'd like to keep them as simple as possible. Let's center the ellipse at the origin. And let's put one focal point out here, right here. Let's say this is the point. Now, the question is right now for me is, do I want to make this an actual number or keep it more general? Now, it turns out here that, wow, it's a tough decision. I really want to keep this general. In some ways, it will make things easier. That may seem hard to believe, but it will. I want to write this point as follows. This is the point C, 0. Now, again, on the letter choice, there's some traditional reasons why I'm using the letter C. I could have used any letter I wanted to, but I'm going to use the letter C. That's typically what you see in textbooks. And here's the other focal point over here. So let's call this the point -C, 0. So we have a point to the right and a point to the left, a focal point to the right and a focal point to the left. And they're equidistant from the origin, and that's going to make things easier. And I'm about to ask you to try to do something rather challenging, and it honestly won't be easy. You'll be able to do it, but it won't seem easy. And so anything I can do to make it easier is good. And I want to make the length of the string L. Let's say L for length of the string. So let's say L is the length of the string. Now, if I had drawn this ellipse, we would get, like say here's the string like this. You could imagine at some particular moment in time as we were drawing the ellipse, there's what the string would look like, and the ellipse would do this. Now again, notice there's no equation here. There's no algebra yet. Let's say this is a typical point right here, and I want to call this the point x comma y. And now I'm about to get some algebra into this. Let's call this d sub 1 and d sub 2. And because it is an ellipse, by the very definition of an ellipse, d sub 1 plus d sub 2 is equal to L. Well, finally we have an equation. But if you've ever studied ellipses before, you know that this is not the equation that people use. So what we're heading towards is we're trying to get the equation that people use. Now, the equation that people use for an ellipse such as this would have the following form. It would look like this. It would look like x squared over a squared plus y squared over b squared equals 1. Well, hold on a second. What's with the a and the b? I don't even see them on this picture. The a and the b are not really even a part of the natural definition of an ellipse. Well, it turns out that this is going to be the point A, same A here, comma 0. And this is going to be the point 0, comma B. Well, how does this become this? Because they don't look the same. They don't look the same. And they don't even have the same letters. Well, what would be something that we could try doing? Look, in a way, you're never supposed to have seen this down here. I know you probably have. If I really knew if I knew you had never seen this before, I wouldn't have written it down, honestly. And I wouldn't have written those 2 points down yet. But I figure you probably have seen it. But if you haven't, I tell you what, for the time being, just forget that. Now, how do you find the distance? Well, we have the distance formula. So let's use it to write an expression for d1 and d2. So look, I want to look at this picture and I want to use the distance formula. So d1 using the regular distance formula would be, now I could try to make things a little bit easy. I could say negative c minus x, but let's say x minus negative c. And that's x plus c, because when you subtract the negative, you get a positive. And then y minus 0. Well, y minus 0 is pretty nice. That's just y. And in a way, that looks awful. But that's what it is. That's d sub 1 plus d sub 2. Well, we do a similar thing for d sub 2 right here. How about let's take x minus c. And here, let me erase this because in a way we weren't supposed to have seen that. You should know about that, the square root there. I don't want to lose track of that square root. And this equals the length of the string. Well, see this equation right here. Even if you, first off, somehow, and I want you to see how, but somehow this equation is going to become that one that I just erased. I mean, it doesn't look like that could possibly happen. Number one, we have different letters. And number two, we just look, we have squares and we have square roots. There were no square roots over there. There were squares, but there were no square roots. Here's two things we have to notice, and I want to show you this because it's not an obvious thing to do. Again, it's like if you're lost in the forest and you're supposed to take a left at the mossy rock. Well, how are you supposed to know that? Well, you probably wouldn't unless you lived in that area and you had explored all around. So in a way, I guess what I should say to you is, if you really want to challenge yourself, stop everything right now and see if you can get this equation to become that one that I erased. I think that's a pretty steep challenge because there's two kind of, I want to say tricky things that I have to show you. They're not difficult to do, but how would you know to do them? It's like maybe like finding a pot of gold if you don't know where it's buried. That's a pretty steep challenge. I would like you to consider the following thing. Let me erase that. I would like you to consider two situations. One is when we're drawing the ellipse and our drawing device, our pen or pencil or what have you, is up there. What would be the case? Well, let's consider this distance right here. C minus 0. So the distance formula. We're going to keep using the distance formula. So C minus 0, C squared, B minus 0, and then square root. That's this distance right here. Well, I could redo it over here, but it's the same thing, right? Because look at the picture. Everything's symmetrical. It's an isosceles triangle. So the two legs of the triangle are the same. So what do we know if we add up these two? 2 times the square root of C squared plus B squared is equal to the length of the string. Doesn't that look terrible? Well, what's the point of that, or what does that allow us to do? It allows us to get rid of L. But before I do that, I want you to consider one other thing, and that's this. Imagine you're drawing the circle, or sorry, you're drawing the ellipse, and here's where your pen is. What would the string look like? Well, it would, I'm trying to indicate what it would look like, but it would basically look like this. Right? I mean, it would actually lie flat, so I can't really show it, but that's the best you could show it. Now, what's this distance? Well, there's a distance of C, another distance of C. That's 2C. So 2C. And then what's this distance here? Well, that's A minus C. A minus C. But there's two of those because look, it goes from here to here and then back. We add up those, and that also gives us the length of the string. Let's go ahead and multiply this stuff out here. Look, 2C plus 2A minus 2C equals L. 2C minus 2C is gone, so L equals 2A. Well, I just got a much nicer version of L, and I think I would like to use that here to get rid of this L. So this L is 2A. So I write down 2C. So 2A. I would also like to use this and substitute it in here. Hey, it's the substitution method. 2A. 2A. Now what happens with the 2's? They cancel each other out. Cancel the 2's out, square both sides, and you get, this was a A. Cancel the 2's, square both sides, and what do you wind up with? You wind up with C squared plus B squared equals A squared. And let's solve this for C. Subtract B squared from both sides, square root both sides, and you get, and I'm going to write it up here, C equals the square root of A squared minus B squared. And I'm going to put that in a box. These are two formulas that I would like you to know. Memorize? No, I don't think it's in the category you should memorize. You want to know they exist and then just look them up. So have this written down somewhere. You can look this stuff up. Certainly, it's in your textbook. It's in any algebra textbook. You could look this up on Wikipedia if you Google ellipse. But like for example, if you go to Wikipedia and you Google ellipse, you're going to get a lot of stuff. It's going to be a tsunami of formulas and equations and symbols, and it might be tricky to weed through. What is this a formula that tells us? It says if we know A and B, we know the length of the string and we know where the focal point is. Conversely, Consider this. Divide both sides by 2. It says A is half the length of the string. So if you know the length of the string, you know what A is. And if you know the length of the string in C, so you can substitute for A, you could substitute in, what did I just say, 1/2 L and C and solve for B. I'll do that later. So what it means is if you know the length of the string and the focal point, you can find A and B. If you know A and B, you can find the length of the string. Actually, there's 4 things there. There's A, B. Those are called the vertices. The vertices. So each one, this is a vertex, 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 collectively vertices. If you know the vertices of an ellipse, then you know the focal point and the length. If you know the focal point and the length, you know the vertices. So there's actually 4 things. There's A, B, C, and L. And if you know any 2, you can find the other 2. That constrains what ellipse we're talking about. Now I'm going to do a thing which is just going to look so unpleasant that if you said to yourself or out loud, wow, that looks horrible, I would agree with you. But I'm going to do it anyways. Here's our equation. I did write down the equation we're heading towards. The equation that we're heading towards only has an A and a B. Only an A and a B. Look at this right here. This has an A but no B but a C. We need to get rid of the C, and here's how we're going to do it. Everywhere I see a C, I'm going to substitute in the square root of A squared minus B squared. So let me do this. Ready? Square root. That's that square root right there. X plus the square root of A squared minus B squared. Now look, that parentheses is there, X is there, plus is there, C is there, parentheses, squared. I can't cancel that square root with that square because this stuff inside the parentheses is a sum. Okay, now plus y squared. That's what I was calling D1, the first distance in that picture that I just erased. Plus the square root of x minus c. I'm going to do the same thing. A squared minus b squared, squared, and then plus y squared. Now, this formula right here, this is important. Let me write it down here. We might need it again, who knows, but I would actually like to have it on this board just to refer to it. I suppose I have these memorized, although I never set out to memorize it. I've just done this derivation so many times, it's stuck in my mind. Okay. Now all that equal 2a. All this equals 2a. That is a terrifying looking equation. How do you come up with the equation of an ellipse? What is an ellipse? It's a set of all points such that the sum of the distances between the point and the 2 given focal points is equal to a constant. It's that picture where you put the tacks into the piece of string and you draw it. That's what an ellipse is. How do you draw an ellipse? Somebody has to come and give you the focal points in the string. They say, hey, here's the focal points. Here's what they are. Here's the string. You can draw the ellipse. We would also like to come up with the equation of the ellipse. The equation of the ellipse. Here, we're not gonna need this right now. We're gonna need that. So again, this is the definition of an ellipse. We came up with 2 relationships down here for the length and the focal point. Actually, look at this right here. We're really saying what is A? It's 1/2 L. And what is C? If I square both sides, what do we get? We get we get C squared. Is it off the screen? Almost. Well, we get C squared equals A squared minus B squared, and then we can take A and put it in here, and then we can solve for B. Fine. So, given C and L, we can get A and B. And we made the substitution. We calculated the distance using the distance formula, made the substitution. We came up with this. I mean, just look at that equation. Here's the deal, or here's what happens. This simplifies. How the heck do you spell simplifies? Isn't it terrible? Well, you can spell simplifies. Where's my spell checker when I need it? This simplifies to the following. And here's the challenge for you. The Mount Everest of the course. Simplified. I haven't done a lot, I would say, in my life. I've probably done that about 50 times. That honestly feels like 49 times too many. But try it. I think it's a fantastic thing to try to do on your own. Yeah. You can look this up, fine. You know, YouTube it or Google it or whatever. Yeah. It's been known for centuries. 500 years, approximately. But that's not the point. You know, if you're going to climb Everest, the point is you're going to climb Everest. Other people, yeah, they've already climbed it. Yep, it's already been done. That's not the point. The point is you do it. You know, that's like anything you do, right? Probably somebody's done it before. Maybe not, but probably so. But you do it. Now, I'm telling you right now, you have the skills to do this. But I can tell you the challenge that's going to be involved here. Well, how would you go about simplifying? Let me give you some hints or suggestions. Number one, you're going to square both sides. And that's a terrifying thought when you look at it. Why would I square both sides? Because I want to get rid of the square roots. If I square both sides, you have a plus b equals this. This side will be 4a squared. No problem. This side, big problem. You're going to wind up with this squared. That'll tear away the square root. It's a special product. It's a plus b all squared. This squared, that'll tear away the square root. Then you'll have plus 2 this times this. Plus this squared, tear away the square root. Well, you still have square roots in there, and then you'll have the plus 2 times this times this. You're going to want to isolate those, the 2 times this, get the other stuff on the other side and square both sides again. And it will be the worst looking equation you've ever worked with. Promise you. I guarantee you. And then sooner or later, you're going to have to multiply this out and this out and do some more squaring. At some point, as I recall, and I don't walk around with this bit of information memorized, even though I've done this 50 times, you're going to wind up with over 30 things on both sides of the equal sign. And if you do everything right and you don't make a mistake, when it seems like all hope is lost, almost everything will cancel out. Miraculously, almost. It's not. It's just the way it works out. And you'll wind up with this. So I suggest this is a once-in-a-lifetime thing. Once you do this once, I can't really ever imagine a reason to do it again. So give it a try, and then we'll continue on with ellipses in the next video.